So now, the basic circuit here is a monostable mode 555 timer. Output's going to be low, the monostable, until we press the button in this case. Then the output goes high for a period of time set by the capacitor and resistor. Not going to dwell on that too much. What we're interested in is usually if I keep holding this button down, once I get a good connection, it was kind of coming out of the board, then the output's going to stay high. But there you can see it did not, because I modified this slightly with the capacitor right there. So we got a little capacitor that helps us overcome this signal being held at the trigger pin. Now, there we go, we actually falsely triggered that. Another thing you could add to this, but in any case, we protection for that. With this little jumper now, it's like that capacitor doesn't exist. We have a direct connection to the trigger pin, and now you can see if I hold it down, the output stays high until I release it. So now, here we have the schematic diagram for the 555 timer in monostable mode, but we added a capacitor so that we can't force the output high for too long. Indicator LEDs to show the high-low status and the timing that we desire. Now, we want to make sure we don't give a low signal to pin 2 for longer than desired. So we have a capacitor. It's going to charge when we press the button. You can see positive goes there, but right when we press the button, this path is going to connect to ground. And as long as the capacitor is charging, it's basically going to pass along that low voltage over to the trigger pin, pin 2. That's why you hold the button. But once the capacitor charges enough, then this becomes more positively charged. You got a higher voltage at pin 2. So that stops holding it low right there. So that's the process for as long as you're holding the button. We'll come to what happens after that in the next short. So now we come back to the schematic diagram for the monostable 555 timer, indicator LEDs to show the output status. Now we press the button to basically charge this capacitor, but it also transferred the low signal to the trigger pin so that it set the output high for the period of time. Now once the capacitor charges though, this side gets more positive. So pin 2, the trigger pin, does not see a low input anymore. It stops doing what it does with the low input, even if the switch is pressed. That's once the capacitor is charged. Now you release the capacitor, the switch I mean, right there, release the switch. Now the capacitor needs to discharge in order to repeat the process. So that's what this other resistor is. Doesn't matter that it's going to the positive supply or whatever, that's all it is a discharge path. And pin 2 still sees the positive supply, so it doesn't care what's going on anywhere else at that moment. So to recap, we have a monostable mode 555 timer. As long as I hold the trigger pin to ground, the output should be high, but we have a capacitor that interrupts things right there. So the output does go low, even though I keep holding it longer than the timing we set at the capacitor and resistor. And there we got the high-low indicator LEDs, our timing circuit for how long the output should be high. But again, the trigger pin, pin 2, can overpower that right there. As long as it's low, the output's going to stay high. So instead, we have a capacitor that passes along that low signal for the time it takes for the capacitor to charge. After that, pin 2 sees a high input. The capacitor is charged. It's also more positive right there. So it doesn't matter that you're holding the button anymore. Now, when we release the button, the capacitor has to discharge. So we have another resistor where we connect the two sides of the capacitor so that it can discharge, and we can restart the process.